All right, welcome to 6.1, part 2. Um, Rational expression. So last time we looked at rational functions and we looked at domain um, and vertical asymptotes. So here, now we're going to look at rational expressions and how to simplify them. Okay, so let's go ahead and write 6.1 part 2, simplifying rational expressions. Okay. All right. So let's just kind of recall just regular numerical fractions for a second here. Okay. So recall when you had something like this, 12 over 18, right? And you had to simplify this, right? And you're like, oh, they have 6 in common. So this would be 2 over 3. And you just kind of do that in your head, right? Okay. So here, it's not that quick. Okay, so, but let's take a look, because what you do in your head is what you're actually going to be doing by hand, because these are a little more complicated, these rational expressions. You're going to be doing what you just did in your head to simplify 12 over 18. You're going to use that same process for rational expressions. So what you actually did in your head was, oh, you factored this out to 6 times 2. You factored this out to 6 times 3, and you use the fact that, oh, well, 6 over 6 and pretty much anything over itself is equal to 1, right? 5 over 5 equals 1, 20 over 20 equals 1, 117 and a half over 117 and a half equals 1. Anything over itself is 1, right? For the most part. So you use that fact to cancel these out, and 1 times 2 over 3, 1 times 2/3 is just 2/3. Okay, so that's how you were able to do it, but you just do it in your heads really quickly. Okay, so what we're going to be doing here with rational expressions is pretty much this exact process. You're going to factor and you're going to cancel like factors. Okay, so let's take a look here. All right, so maybe you have something that looks like this, that factors out to x plus 5, x minus 1, right? When you factor it. And then when you factor down below, you end up with x plus 2, x minus 3, x plus 5, right? And so just like over here, the common factors will cancel. Same thing here. So the common factors will cancel. So x plus 5 will cancel. And you're left with just x minus 1 in the numerator, and you're left with x plus 2, x minus 3 in the denominator. So this would be your final answer. Okay? All right, so hopefully you have mastered the art of factoring. All right, let's start off with some a little bit more simple ones. Okay? All right, so let's take a look at this. Let's go ahead and simplify. And suppose that I have this 8yz to the fourth over 6y squared z squared. Okay. All right, so over here, starting with the numbers, we know that they have 2 in common. So if you divide them both by 2, you get 4 over 3, right? So we're going to get 4 over 3. And then over here, this y will cancel out with one of these. So these might get a little messy because they have exponents. So that one will cancel out with only one of these. So we're left with 1y down below. Okay. These two will cancel with 2 of these. So all of these will cancel with 2 of these, but I'm left with 2. Okay. And that would be your final answer. Okay. Kind of made a long fraction bar there. Okay. And let's take a look at this one. Simplify. 6x squared over 3x to the fourth minus 9x cubed. Okay, so we need to factor. The numerator cannot be factored, so we'll just leave it as 6x squared. Down below, well, I see that they have 3 in common. They also have x cubed in common. So I'm going to factor out a 3x cubed. And when I do that, I'll have x minus 3 left. Okay? And then now I can cancel these. The 6 and 3 have 3 in common. Okay? Here, I'm going to use red. Or maybe I'll use blue. Okay. So here, the 3 and the 6 will cancel, leaving you with 2. All of these will cancel, but you'll be left with 1. And that's it. That's all you can cancel. So we're left with 2 in the numerator. I'm left with an x in the denominator and also an x minus 3. Okay. All right, let's take a look at another one. Let's simplify this one. X squared minus 16 over 2x squared plus 8x. Okay, so over here, the numerator is difference of squares. So I'm going to factor that, x plus 4, x minus 4. Okay, so that's what you need to do here. So here, maybe we should put a note here at the very beginning here. Where is it? Okay, so right over here, let's start from here. Factor completely. Then cancel, if possible. Okay, so that's what you're doing for these problems. Factor completely, then cancel if possible. So here, we're going to factor completely. So up here, we have perfect squares, difference of squares. So it's x plus 4, x minus 4. Down below, this is common factoring. So I'm going to factor out a 2 and an x. So I'll have x plus 4. And you can always check to see if you get that back. 2x times x is 2x squared. Check. 2x times 4 is 8x. Check. Okay. And then here, I can cancel out those. Okay. So my answer is x minus 4 over 2x. Okay. Make sure, see how this 4 is connected to this x by subtraction. If it's connected by addition or subtraction, you can't cancel it. Okay. So do not cancel the 2 and the 4. I see that every single year, every single semester. Okay. So if it's connected by addition or subtraction, you cannot cancel it. Okay. All right, let's take a look. Let's simplify this one. X squared minus 10x plus 25 over 8x minus 40. All right, so let's factor completely. So this is trinomial, so it's this kind. X times x to make x squared. And then I want to make positive 25, so the signs have to be the same. This tells me they'll both be negative. And looks like it's going to be 5 and 5. Okay. Down here, this is common factoring. They have 8 in common. So I'll factor out an 8, and I'll have x minus 5, because 8 times x is 8x. 8 times negative 5 is negative 40. And then here, I can cancel those, and I'll be left with x minus 5 over 8. Okay, see how that works? All right. And what about this? Don't shut off yet, because even if you think you got this, because there's something at the very end that I need to point out, okay? We'll do 2 more examples, and then I'll do the thing that I want to point out. Okay, so example 5. Let's simplify. We'll do one more, and then I'll point it out. 6a squared minus 13a plus 6. 3a squared plus a minus 2. All right, so let's factor this completely. I think we did this one previously, right? It was 3a times 2a. And then the signs have to be the same, both negative. And then 2 and 3. So let's see. Outside is negative 9a. Inside is negative 4a. Negative 9 and negative 4 is negative 13. So that checks. Down below, that is 3a times a. The signs have to be different. Since I'm aiming to cancel, I don't know where the plus and the minus go, but since I'm aiming to cancel, I'm going to guess that this one's going to be a minus 2 probably. So I'm just going to try the minus there and the positive here. And then we need to make 2. So 2 here. That's not going to work. 2 here and 1 here. All right, so let's check to see if we get 1a for the middle. Outside, positive 3a. Inside, minus 2a. 3a minus 2a is 1a. So this is the correct factoring. And then here, they cancel, and you're left with 2a minus 3 over a plus 1. Okay, now take a look at this example. This is where I need to point something out. Simplify. Now, suppose that you have this. Remember, for subtraction, order matters. Do not change that around to x squared minus 25. You cannot do that. You have to keep it that way. Okay. And then suppose that you have this here. X squared minus 10x plus 25. Okay. All right, so let's go ahead and factor this. So that's perfect squares. Again, you have to keep it in this order because it's subtraction and order matters. Okay, so when we factor that, it's going to be 5 plus x, 5 minus x in that order. Very important. Students will switch this order because they want to see it look like this. You can't, okay? You can't just make it what you want it to be, okay? All right, and then down below, we have x times x. Both signs the same, both of them negative. 5 and 5, okay? So here's what I want to point out. So here's the question, $1 million question. These down here are not exactly like these up here, right? These are kind of close, right? But not exact. So the question is, can we cancel them? What do you think? Can we cancel them? Okay, so here's the answer. Let's take a look first with some concrete numbers, no x's. Okay, let's suppose that we have this 5 minus 3. What does that equal? 2. Now let's switch it around. 3 minus 5. What does that equal? -2, right? So if I have 5 minus 3 over 3 minus 5, that's going to give me 2 over -2, which is -1, right? So let's change those 3's to x's, right? If I have that, right? It's still going to, whatever that number is, it's going to be the same number on top as the same number on the bottom, except one of them is positive, the other one is negative. So it's always going to equal -1. Okay, so can you cancel these? Yes, you can cancel them, but you have to put -1. Okay, so the final answer here is negative. You can write this one as x plus 5 because addition you can flip. It's if you do 5 plus 3, 3 plus 5, they're the same. It's commutative. X minus 5 here. Okay. All right, so that's all I wanted to point out. So that is the end of 6.1 part 2 video. All right, make sure you guys keep up with the homework. Make sure you message me if you have questions.